Okay, so hi students, this is Dr. Zhong. Good evening. So today I'm going to stay at my home and record this video lecture for you. So before I start, I want to talk about the feedbacks that I hear from you. So the first feedback, yes. The first thing that I heard from most of the students are about homework 1. So I think I received the help from around 14 students, and I think I replied all of them at least so by Friday afternoon. So most of students who sent an email to me had a difficulty with starting the homework, and I think so it takes time for you to adapt to say the scenario without, for example, without the help of program platforms like my programming lab. But when as we step into the semester gradually, you will be able to be adjusted to this setting, and which is pretty much like the environment that you are going to have when you go to your job. And so that is homework 1. And then the second one is is a vote on say which way of remote learning that you prefer. Previously, I give you two options. A is that I take a video lecture at the classroom, and like the video that I uploaded for the first week. And then the second option is that I stay at home, and then I use my iPad Pro to record the video. So based on all the votes, and I ask you to share your opinion with me by sending an email to me. Okay, so based on the emails that I received from this topic, on this topic, 100% of the students vote for option B, and most of the reason are that the voice is louder, is clear, and also the video quality is better, because at the classroom they only have the 720p video web camera, plus I just checked with the facility say department of the campus today. They still have not fixed the light in the front of the classroom. So if I'm going to record a video tomorrow, it still is going to be dark, and it's not going to be clear from the web camera. So I think that you made a good choice. And because when I stay at home, at least I can guarantee the visual quality and the voice quality. So and then the third is the plan for the section of CSIT 2002. So because this semester I'm teaching two sections of CSIT 2012. One is the section 02, and the other one is section 03. So this previously I planned to have in-class meetings for CSIT 2012 for the 02 section at Monday around 2:15 p.m. to 3:30 p.m. So that is the old plan, and so because most of the students vote for the option B, so what I'm going to do is that I'm going to cancel the face-to-face meeting for the section of 02. Okay, so there is no face-to-face meeting at this time. But if you want to come to the if you are the students in the section of 02, and if you still want to come to face-to-face meeting, you are more than welcome to the face-to-face meetings for the 03 section. So, and their class time is scheduled at 5:30 to 8 p.m. on Mondays. Okay, so you are welcome to come this classroom. There will be enough capacity, even though we are under the COVID-19 capacity, which is so which only allows, let me say, around 16 or 18 students to come into the classroom. But based on the previous doodle survey that I did, this classroom is good enough to hold the students from these two sections who want to come to the classroom. Okay, so feel free to come, and I'll give my face-to-face meeting, face-to-face lecture at this time, and the classroom is Science Hall 102. So you're welcome to the face-to-face meeting at this time. And okay, so this is what I based on what I got from you to just give you an update. And now let's come back to a review. So last week we mainly learned a new sorting algorithm called merge sort. And so in merge sort, we say that we follow a very important design called divide and conquer. So divide and conquer. So in divide and conquer, we resolve the problems in 3 steps: divide, conquer, and combine. So divide is like we split a very complicated and big problem into several small parts, and then conquer is that we focus on each individual part and solve them. Combine, in the combine step, we combine the solution together. So so in merge sort, the divide step is very easy. We just split the array into 2 if it includes more than 1 element. And then in the conquer step, we basically do nothing. While in the combine step, we combine two small sorted array subarrays into a big and sorted one. So most of the work are done at the combine step. And also we said that the complexity of the merge sort is O(n) log n. Okay, so where n is the size of the array. And also I briefly talked about heap sort. So this one is very complicated, and because it relies on it relies on a data structure named max heap. And so this one I take it as optional. So if you have interest, feel free to read the corresponding chapters in the book and understand it. So okay, so this is what we learned from last week, and today we're going to have our last lecture on sorting algorithms. And today we're going to learn 2 sorting algorithms. One is called quicksort, and the other one is called counting sort. So quicksort follows the same design as merge sort, which is divide and conquer. So like what I mentioned previously, in merge sort we do most of the work at the combine step. However, in quicksort we do most of the task in the divide step. So let me give you a brief introduction of the key idea behind quicksort. So in quicksort, let me just give you let me use a different way to explain. So suppose that here we got 5 students. We got 5 students which just sit randomly in a classroom. Let's say we have, no, let me make it a little bit better. So I'm going to make this one higher. No. So let me. Okay, so here we got 5 students in the classroom, and I want to sort them in ascending order based on their height. So if we follow quicksort, the way is that, okay, so first I'm going to take the last student. I'm going to say I'm going to use you as the standard. Okay, I'm going to take the last student as the standard. Whoever is shorter than you is going to go before you, and whoever is higher than should go after you. So based on this command, so I'm going to arrange the students in this order. Okay, so I'm going to put all the people who are shorter than this student in the front, and then put all the students who are higher than the last one in the after him, and then I'm going to insert this one, insert the last student just in the middle. Okay, so what I know is that, so here what I know is that all the students before the last one, before the right student is shorter than him, and all the students higher than him after him is higher than him. So next, with this, I know that this student is in the correct place. Sorry, I shouldn't put this one. This student is in the correct place because there are two students that are shorter than him and two students that are higher than him. So in a sorted order, he should be at this place. This student should be at this place. So then I'm just going to follow the same philosophy to sort to arrange the two students before him and two students after him. So then I'm going to get all the students sorted, so based on their height. And this is the way that this is how quicksort works. So basically, in each step, it just takes the last student as and last element in the array as the pivot, and in a divide step, it is going to make sure that, okay, all the numbers that are smaller than the pivot, we call this one the pivot. Okay, so all the numbers that are smaller than the pivot should go before the pivot. That is what we do in a split step. In a split step, we have the pivot, and then all the people who are all the numbers who are after the split step, we want to make sure that all the numbers that are before the pivot are smaller than it, and all the numbers that are higher than the after the pivot are higher than it. So, and then we in the concur step, it's it is going to say repeatedly then in the next step it's going to repeatedly apply the same procedure and arrange all the numbers in the first subarray and last subarray, and leave the pivot unchanged, and it's going to repeat this procedure until we got all the numbers sorted. But in the combine step, we just do nothing. And so that's why we say that most of the work are done in the divide step. And this is the pseudocode of quicksort. It has two pieces of functions. So the first function is like the main function. It is like the main entrance of the algorithm. While so this function called partition does the split task. So first I'm going to discuss the partition. I'm going to discuss the partition function, and then the quicksort algorithm is going to be is going to be relatively easy to understand. So here I'm just going to it's at the wrong place. I'm going to delete it, and I'm going to add a page before it. Okay, so just right over here. Okay, again I'm going to write down the pseudocode first. Partition APQ. So we will get, it's APR, not APQ. We have x equal to AR and I equal to P minus 1. And for j starting from 1 to R minus 1, j starting from P to R minus 1, if a j is larger than x, then we're going to increase I by 1, and then we're going to exchange AI and AJ. And then we remove this part. So then we're going to say at last we are going to right over here we're going to exchange AI plus 1 and AR. So this is the pseudocode, and then let's use an example to go through it. So here again, suppose that we have a very long array, and let's just focus on a small part of it. We have numbers 2, 8, 7, 1, 3, 5, 6, 4. Okay, so we have an array A, and so this is what we have so far. Okay, so first let's look at the pseudocode. So the function name is partition, and then so here we have the input parameter capital A. So if you are so I think at this time you should have the instinct to know that A means the array to be sorted. And then we have P and R. So let's say, I'm not sure if you still remember, in merge sort, in the combine function, we also have similar parameters. We have A, P, Q, R. So like we use P and we use P we use P, Q, R to denote the index of the subarray to be sorted, right? So right over here, yes, the P and R have similar meanings as merge sort. P means the starting index of the subarray, while R means the ending index of the subarray. So here for this array A, we are going to say no matter how long it is, we are going to focus on this part. We want to apply the partition function over on this part. So we are going to mark P over here and and R over here. So P is the starting index of the subarray to be sorted, and R is the ending index of the subarray to be sorted. So first, and then we're going to pass these parameters APR to the partition function and to see what is the result. So first, let's say we have X equal to AR. So because R is at the last place, R is right over here. So then we will have AR is 4. So AR is 4, and then we're just going to create a local variable whose X and its value is 4. Okay, and then next we have I equal to P minus 1. So the next line is that I equal to P minus 1. So P minus 1 refers to the index just right before P. So initially we have I right over here. Okay, and for J starting next in a for loop, we have for J starting from P to R minus 1. So the starting value of P is the starting value of J is P. So J and P refer to the same place in the beginning. All at the first all refer to the starting index of the array. So first let's check if AJ is larger than X. So what is AJ now? So we have AJ as 2. So it's 2. So what is X? X is 4. So this is false, right? So because this is false, so we're not going to do anything. So the if statement is the if condition is going to fail. So we're not going to do anything. And and then so we're going back to the double check. Yes, we're going back to the for loop. So we are going to increase j by 1. So the new value of j, so we are going to put j at this place. So j is going to stay right over here. So we have, so now let's check the value of aj. So now aj is not 2 anymore. It is what? It is 8. So aj is 8. So, and while x remains unchanged, so this is going to be true, and which means that we will be able to execute the two lines inside the if statement. So first we are going to increase I by 1. So I move one place to the right. So I moves here, and then we're going to exchange ai and aj. So here we're going to exchange oops, sorry, I think that I made a mistake when I was writing the pseudocode. Okay, so let me say this is less than or equal to. Okay, so then don't worry, let's restart the execution of the algorithm. So so again, let's say that we pass in the values with p, q, and r. So this is p, this is r. Okay, so p and r and the array a. So we have x equal to 4 and I equal to p minus 1. I is right over here. For j starting from p to r minus 1. So initially the initial value of j is p. So j also refers to the first place of the subarray. So if aj is less than or equal to x, so we have x as 4, and here aj is 2. So sorry, this is true. This should be true. And then we're going to increase I by 1. So I is going to be increased. I is going to be moved one place to its right because we increase its value by 1. So right now we have both I, j, and p refer to the same place. So then we're going to execute this line. We're going to exchange ai and aj. So because I and j refers to the actually have the same value. So let me say, let's just for example, we have I and j equal to 10. Both of them equal to 10. So then this line is going to be exchange a 10 and a 10. So do you know what is going to happen? So it's like we're going to replace we're going to exchange say two values at the same place. It's like we're not going to change anything to we're going to make any change to the array, and so everything remains the same. And next, so after that we're going to go back to the for loop. Then we're going to increase j by 1. So now we move j right over here, one place to the right, and then we have we have aj equal to 8. Okay, so this is going to be false. So we're not going to do anything. Okay, we're not going to do anything at this run of the for loop. So then we go back to the for loop, and then we increase j by 1. So we move j right over here, and now the value of j is what is 7. Sorry, aj is 7. So again, this is false, and so we're not going to be able to enter the two lines inside the if statement. So we do nothing. And next, we are going to, let me move I to this place. So then we're going to go back to the for loop and increase j by 1. So j is going to be at this place. Okay. So the new value of aj is what is 1, and then this if condition is going to be true. So next we are going to increase. So we are able to execute the two lines inside the if statement. So we're going to have I plus plus. So we increase I by 1. I goes right over here, and then we're going to exchange ai with aj. So let's say we have ai right over here and aj right over here. So we're going to exchange them. So we are going to move to switch their place. So now 1 goes to this place and 8 goes to this place. And this is the change that we're going to, we are going to have at this run. Okay, so let's see now. Okay, so we have I at here and j at here. So let's say, can we safely claim that all the values starting from p to in the array whose index starting from p to I are smaller than or equal to x or pivot? So because x, this is x, this is x. So can we say that all the values between p and I in the array between p and I in the subarray starting from p to I is less than or equal to x, and all the values starting from I plus 1 to j in the subarray starting from I plus 1 to j is larger than x? Yes, this statement remains true. It is true right now because as we have this part starting from p to I less than or equal to x, well, starting from I plus 1 to j, all the values are larger than x. Okay, so this remains true in this iteration of the for loop. So then let's go back to the for loop. So we are going to go back to the for loop, increase j by 1. So now we are going to increase j by 1. And now we have aj as 3. So 3 is less than 4. So this is true. And then we're able to execute the 2 lines inside the if statement. So we're going to increase I by 1. So I goes right over here. And then, so we're going to exchange ai with aj. So we're going to exchange this value and this value. Okay, so we are going to move 3 right over here and 7 right over here. Okay, so okay, then we finish this iteration of the for loop, and when we after we finish this iteration, let's double check if this is true or false. So are all the values starting from p to I in the array whose index starting from p to I in the array less than or equal to x? Yes, 2, 1, 3 are all smaller than x. Well, are all the values starting from I plus 1 to j larger than x? Again, it is true. So this again remains true. And then let's go back to the for loop. So we are going to start another iteration of the for loop. And in the beginning, we increase j by 1. So j goes to this place. And the new value of aj is 5. So, and this condition is going to be false. So we are not going to be able to do anything in this run. And then, so we are going back to the for loop. So we are going to increase j by 1. So j moves here, okay? And then the new value of aj is 6. Again, this is false. So this if statement is false. So we are not going to be able to do anything. And now when we finish this iteration, let's check if the condition is true or false. All the values starting from p to I are smaller than x, which is 4. All the values starting from I plus 1 to j are larger than x, which is 4. Yes, it's true, right? Yes, these two claims remain true at all time in a for loop. And after we finish this iteration of the for loop, we just finish the for loop because j already reaches its maximum value, which is right over here. Its maximum value is r minus 1, and j is at r minus 1. So we cannot increase j. We cannot start another iteration. So we reach the end of the for loop, and then so let's say what's next. We're going to exchange ai plus 1 and ar. So we have I right over here. I is right over here. So I plus 1 is right over here. So we're going to exchange these two values. Okay. So what we end up with is here. We are going to move 4 right over here and 8 right over there. Let me mark 4 with red color because that is the pivot. That is x. Okay. So then we just finish the partition function on this input instance. So let's say at the end of the for loop. at the end of the partition function, what we have is that, okay, we have the pivot in this place. All the values before the pivot, before the pivot are smaller than it, and all the values after it are larger than it. So that is what we want to have for the for loop. And in the last, you need to remember that we are going to return I plus 1. Okay, so now let me ask you a question. What is I plus 1? What is I plus 1? I plus 1 is the index of the pivot. Okay, that is the index of the pivot. It just informs, okay, after we make these arrangements, okay, so we move the pivot from the last place of the subarray to which place. Okay, so this is the example, and so hopefully that you can understand it. And then let's look at the quicksort function. So the quicksort function takes 3 parameters: APR. Again, A is the array, P is the starting index, and R is the ending index. So what it does is that if P is less than R, so if you remember, if P is less than R, what does that mean? It means that the subarray size, subarray length is larger than 1. Okay, so it means that there is a need for us to sort. So what it does is that, okay, so it first calls the partition function over the subarray. So for example, initially we have this. Initially we have a subarray to be sorted, and here is this is the pivot. Okay, this is the pivot. I'm going to mark X is in the end. After, so it's just the last element in the array. Okay, and then next, so in the second line it calls the partition function and returns Q. Okay, so by calling the partition function, we're going to rearrange the array such that we put X someplace in the middle, and all the elements before it is smaller than, and all the elements after it is larger than it. And so now it just returns the index of so here I'm going to mark P and R. So this is P and R. Okay, so then by returning the index of the array and by returning the index of the pivot and assigning it to the variable Q, so we know that, okay, the pivot X is located at this place. So next it is going to call the quicksort function over this subarray whose starting index is P, ending index is Q minus 1, and over this subarray whose starting index is Q plus 1, ending index is R, to arrange the elements in these 2 subarrays separately. So finally, if we can get all the if we get only single the subarrays only include single elements, and each of them follows this condition, we know that we get everything sorted. So this is the idea of the algorithm. Okay, so this is quicksort, and so from the name probably you can tell that quicksort is really fast, but in theory it's not. Its complexity is going to be the same as worst case complexity is going to be the same as insertion sort. It's not very fast. It's in the worst case it is n squared, but on average in practice it's very fast. It can give you on average it gives you n log n complexity, which is comparable to merge sort, but in practice it is the most efficient one. So which means that, okay, if you go to a job interview, and if the interviewer asks you to implement a sorting function without any, even though the interviewer does not explicitly mention that you need to implement insertion sort, you need to implement quicksort, you should still go for quicksort because it demonstrates your knowledge of the complexity. You know that quicksort is the most efficient one. So that is the standard in industry. Okay, so this is quicksort. And next I'm going to talk about the other algorithm named counting sort. So actually this is the favorite sorting algorithm, my personal favorite sorting algorithm. So previously, let's just go through all the sorting algorithms that we have learned. We have insertion, whose complexity is what? O(n) squared. We have merge, whose complexity is O(n) log n. And then we have quicksort, whose complexity is O(n) squared. But in practice, it's very fast. So among all these three algorithms, which one gives you the best worst case complexity? Yes, it is the merge sort, because its complexity is O(n) log n. And so my next question is that, can we do anything better than n log n? Yes. The answer is yes. Otherwise, I wouldn't ask it. So we have an algorithm which can give you this complexity, O(n) plus k complexity. And k is, so for now you can take k as a constant. I'm going to introduce k later, okay? So which means that, okay, if k is less than or equal to n, we can just take it as O(n) complexity. And O(n) is definitely faster than O(n) log n. So the algorithm that can give us O(n) plus k complexity is named counting sort. And this algorithm is very beautiful, but it has some limitations. So that's why in practice we don't use counting sort very often, just because of the limitation. Okay, so the limitation is that if you want to use counting sort to get O(n) complexity, you have to, the array that you want to sort must satisfy the following says a requirement. So all the values in the array are integers from 0 to k. Okay, so all the values in the array must in the range from 0 to k, and also integers. So k means the maximum value, integer value in the array. So if the array that you want to sort satisfies this condition, you can use the counting sort to make the sorting very fast. So this is the limitation. And next, I'm going to present the pseudocode. The pseudocode looks very confusing. So let's go through it. So first, it takes three input parameters, abk. So unlike previously, we only take a single array, A. Now it takes two arrays, A, B, and K. So A, B are the two input arrays, and K is just the maximum integer value in the array A. Okay, so let's look at what does this algorithm do. First, it creates a new array whose variable name is C. And then for loop, in the first for loop, it assigns 0 to everything in the array C, and then it has another for loop, and then it has another for loop, and last it has another for loop. The last for loop is really like very hard to understand. BCAJ equal to AJ. So what does that mean? So next, my task is to explain it for you. Okay. So again, I'm going to use to go through it line by line. So let me just add a note, add a page. So yes, so now I got the page right over here. So we have counting sort, abk, let C0 K be a new array, and then for I starting from 0 to k, it assigns 0 to it, and then for j starting from 1 to a dot length, it has CAJ equal to CAJ plus 1. And then it has this for k starting from, for I starting from 1 to k, it has c I equal to ci. We write it in a better way, okay? So ci minus 1 plus ci, and next has 4 j starting from a dot length minus 1 to 1 b c a j equal to aj, and then it has c aj minus. Okay, so this is the input, and then this is the pseudocode. Then let's look at an input instance. So suppose now we have an array A whose size is like this, whose value is like this: 2, 5, 3, 0, 2, 3, 0, 3. Okay, so and the index of these values starts from 1, 4, 5, 6, 7, 8. So here we got 8 numbers in the array A, and so A is the array that we want to sort. So let me ask you a question. What is k? What kind of value should k be? So if you remember, k refers to what? Refers to the maximum value in the array A, integer value in the array A. So here we have k. We have k as 5, because 5 is the maximum integer value in the array. And now let's double check if all the values in the array A are integers from 0 to 5. Yes. Okay. And now, so let's check another. Let's say what is B. So B should be an array with the same size as A. So, and initially it is just empty. So here we have B as this. So B is an empty array whose size is the same as A. And then so we have A, B, and K. So now we're going to pass in these 3 parameters into the counting sort pseudocode, and let's run it. So first we're going to create an array C, so whose index are from 0 to K. So now let me ask you a question. What is the size of C? Think about it. What is the size of the array C, or what is the length of array C? So some of you may say it's k, while some of you may say it's k plus 1. So guess what? It should be what? It should be k plus 1. Because the index starts from 0 to k. If it starts from 1 to k, then its size will be k. But here, because the index starts from 0 to k, so its size should be k plus 1. So let's use the index. So k, the array C is a little bit special because its index starts from 0. Okay, so this is what you need to pay attention to when you are doing your homework 3. So next, let's say in the next for loop we have 4 I starting from 0 to k, and we have ci equal to 0. So as what I mentioned previously, we basically use I and j as the index of the array. So similar here, we are going to use I as the index of the array C. So in this for loop, initially we have I equal to 0. So what we do is that we're going to do this. We're going to assign 0 to 0. So the first place, so here we're going to have 0 in the first place. And in the next run of the for loop, we're going to increase I by 1. So we are going to have C1 equal to 0, so which means that we assign 0 to C1. So in the next run, we just replace this one with 2, so we're going to assign 0 to C2, and then C3, C4, and C5. Okay, so this is what we do in the first for loop. We just assign 0. Okay, we just assign zeros to the array C. And next, so let's just check the next loop. For j starting from 1 to a dot length, and so the length of a is just 8. So for j starting from 1 to 8, we have CAJ equal to CAJ plus 1. So initially we have, let me put j over here, okay? Initially j is 1, so AJ is 2. So we have AJ is as 2. So this sentence will be, let me mark k over here, okay, k equal to 5, okay? So here we have, if we replace AJ with 2, it will be C2 equal to C2 plus 1, right? So we're going to add 1 to C2. So originally C2 is 0, so now it becomes 1. And next, we're going to increase j by 1. So j comes to here. J is 2. Okay, so then we have AJ as 5. AJ as 5. So it will be C5 equal to C5 plus 1. Okay, C5 equal to C5 plus 1. Originally C5 is 0, so now its new value is 1. And next, we're going to increase j by another one, so j becomes 3. So because AJ is also AJ is 3, so it will be C3 equal to C3 plus 1. C3 equal to C3 plus 1. So we just give it a new value 1. And then next, we're going to increase j by 1. J becomes 4. We have AJ as 0. So we have C0 equal to C0 equal to C0 plus 1. So for this cell, its new value is going to become 1. And next, we're going to increase j by 1. So AJ becomes 2. So it becomes C2 equal to C2 plus 1. So originally C2 is 1, so now C2 becomes 2. So next, we're going to increase j by 1. J becomes 6. So AJ is 3. So it becomes C3 equal to C3 plus 1. C3 equal to C3 plus 1. So originally C3 is 1, so now it becomes 2. And next, we move j one place to the right, and then CJ is 0. Okay, so AJ is 0. I'm sorry, AJ is 0. So we have C0 equal to C0 plus 1. And then we're going to replace this with 2. Okay, so next we're going to give j a new value, which is, so j becomes 8. And then AJ is 3, so it becomes C3 equal to C3 plus 1. So original C3 is 2, so now it goes to 3. Okay, so then we just finished the second for loop. Okay, so we just finished the second for loop. Now let me ask you a question. What do we do in the second for loop? So guess what we do? Some of you may say, okay, we just go over everything in the array A and make some change in array C. Yes, but what does every element in C stand for? So let me, take a couple of seconds to think about it. If you want to make a parse, you can make a parse by yourself manually. But now I'm going to let you know what does this do. Okay, so if you want to, when you watch this video, if you want to make stuff, feel free to do it and to think about my question. Okay, so and when you're ready, just re-click the start button. So here, let me ask you one question. Okay, so how many zeros does the array A include? So we got 2 zeros. So right, 2 zeros. So we got C0 equal to 2. So how many ones does the array A have? We got no one. There is no one. So the count of 1 is basically 0. So we have C1 equal to 0. How many 2's appear in the array A? We have 2 2's, right? So then we have C2 equal to 2. how many 3s show up in the array A? You got 1, 2, and 3. So okay, so there's three. There are basically three threes in the array A. So we have C3 equal to 3. How many 4s are there in the array A? There is no 4. So the count of 4 is 0. So that's why we have C4 equal to 0. How many 5 are there in array A? Only 1. So we have C5 equal to 1. So here, what do we do in the second for loop? Count the frequency of values. Count the values, or count the frequency of the values. Yes. So basically after that we see I represent the frequency of I in A. In array A, right? So this is what we do in the second for loop. Okay, if you were able to figure out the correct answer of my previous question, which is what does the second for loop do, then you are, I'm really proud of you. So next, let's go to the third for loop. So for I starting from 1 to k, we have say I equal to say I minus 1 plus say k. Okay, so here, let's say initially we have I equal to 1, so I equal to 1. So say I equal to say I minus 1 plus say I. So it is say 1 equal to say 0 plus say 1, right? So it's like we are going to add say 0 to the value of C1. So originally C1 is 0, so now it becomes 2. And then we increase I by 1. So the new value of I is 2. So it becomes, so this for loop, in this for loop we have C2 equal to C1 plus C2. So this is like we are going to add C1 to C2. So originally C2 is 2, so now it becomes 4. And next we're going to increase I by 1, so it becomes C3 equal to C2 plus C3. So the new value of C3 is going to be 7. And then in the next one we just increase I by 1. I becomes 4, so it becomes C4 equal to C3 plus C4. So originally we have C4 equal to 0, so its new value is 7. Okay, and the next, okay, so we have we increase I by 1, I becomes 5, so it becomes C5 equal to C4 plus C5. So this value goes from 1 to 8. Okay, so what does this loop mean? What do we do in this loop? So let me ask you one question. Okay, in the array A, how many values are less than or equal to 2? Are less than or equal to 0? 1 and 2. So we got 2 values less than or equal to 0. How many values are less than or equal to 1? Still 1, 2. So only zeros in this array. Only zeros are less than or equal to 1. So it is still 2. How many values are less than or equal to the value of 2? So we got 1 right over here. So let me mark it over here. We got 1. No. So yes, let me use this one. Okay, we got 1, 2, 3, and 4. 4 values are less than or equal to 2. So that's why we have the 4 over here. Okay, so how many values are less than or equal to 3? We got 1, 2, 3, 4, 5, 6, 7. 7 values are less than or equal to 3. Yes, so that's why we have C3 as 7. So basically after this loop, so this loop basically tells us how many values are less than this loop yes, this loop just tells us how many values are less than or equal to a certain value. So, okay. Okay, so okay, before we start the last for loop, I'm just going to ask you one question. Okay, so let me say, okay, if I tell you that, still, I'm saying that I want to sort all the students in a classroom based on the height. If I tell you that, okay, you are, so sorry, there are 7 students that are less than or equal to your height, including yourself. There are 7 students who are less than or equal to your height. Do you know, if I want to get all the students sorted based on the height from the shortest to the highest, do you know which place should you go? You can safely stay at the 7th place, because including yourself, you rank the 7th. You rank the 7th in the whole classroom based on the height. So you should just, if I tell you that there are 7 students that are less than or equal to your height, you should feel pretty confident to go to the 7th place, saying, okay, I'm at my correct place, right? Yes, if you understand that logic, then it's going to be much easier for me to explain the last for loop. So first, again, let me follow it step by step. So first, it has for j starting from a, the length of a to 1. So initially we have j equal to 8. So j points to this place. BCAJ equal to AJ. Wow. Yes. So what is AJ? Now what is AJ? Let's figure it out step by step. AJ is what? AJ is right over here. It is 3. Okay. So we have AJ as 3. And what is CAJ? CAJ is like C3, right? So C3 is what? C3 is 7. So what does this C3 mean? There are 7 values which are either less than or equal to 3. So, or in other words, the correct rank of the value 3 should be what? Should be 7. So we should be pretty we should feel pretty comfortable to assign to put 3 in the 7th place of the sorted array, right? So next, so then it has B CAJ equal to AJ. So we have CAJ as 7, AJ as 3. So in total, it will be B7 equal to 3. So it's like we are going to assign 3 to this place. So we say, okay, this student, you should go over there because you rank the 7th in the whole classroom. Yes? And then it's like we just move the student out of the pool of the students to be sorted. It's like we're going to cross it out, and then we're going to decrease CAJ by 1. So AJ is what? AJ is 3. So we're going to decrease CAJ from 7 to 6, because the reason is that okay, so the value goes from 7 to 6. The value for us to do that is that, okay, this student is already removed. So among all the remaining students, there are only, among all the remaining numbers, there are only 6 that are less than or equal to 3. Okay, so that's why we decrease it by 1. And then in the next one, we decrease j by 1. So j, sorry, this is still 8. So j goes from 7 to 8 to 7. J is here. Okay, so now we have AJ as what? We have AJ as 0. Okay, so then let's check what is C0. So now we know this part is, we know that AJ is 0. So AJ is 0. Okay, AJ is 0, and then C0 is what? Let's check the table. CJ is 2. So okay, So then next we know this part is 2. Okay, we know this part is 2. What we're going to do is that we're going to assign 0 to b2. So it's like we know it's like after we see a number 0, we know that there are two values that are smaller than or equal to 0, which means that the correct rank of 0 should be 2. So we just move it to this place. And next we're going to decrease, and we're going to cross it out. We're going to decrease the value of C0 by 1. So originally C0, so C0 is 2. So we're going to decrease it from 2 to 1. Okay, so this is what we do. And the next, we're going to decrease j by 1. J goes to 6. So and then we have aj as 3. We have aj as 3. We have c3 as 6. C3. So here. Now I'm not going to write down everything. Okay, I'm just going to say we have aj as 3, and c3 is 6, which means that the correct rank of 3 should be 6. So it's like we're just going to put it in the 6th place of b, and then so it's 3, and then we're going to cross it out, and then we're going to decrease the value of c3 by 1, so it becomes 5. And in the next round of the iteration, we're going to decrease j by 1. J goes here, so we see aj as 2. So c2 is 4. So we're going to assign this 2 to the 4th place in the array B. So it's like we're going to move it right over here. We see that your correct place is the 4th place, and then we're going to cross this value out. Then we're going to decrease c2 by 1, so it becomes 3. And next we decrease j by 1. J goes over here, and we see a value that is 2. So sorry, that is 0. Okay, so we have c0 as 1. So we know that the correct place of 0 should be 1. So we just move it to the 1, cross it out, and then we decrease c0 by 1. Okay. And next we see a value that is 2. Sorry, we decrease j by 1. So j goes right over here, and then we see we see aj as 3. So c3 is 5. So we know that we should put it in the 5th place, 5, and then we cross it out. And next, so we decrease the value of cj or c3 by 1. So this new value is going to be 4. So next we just decrease j by 1. So j goes right over here, and then we just say aj as 5, and we have c5 as 8. So we know that so 5 should go to the 8th place. Okay, and then we're going to cross this value out, and then we're going to decrease c5 by 1. So and then we're going to decrease j by 1. Okay, so then the value that we see in A is 2. So we have c2 as 3. So we know that we should put it in the third place, and then its value is 2. We just assign value 2 over here. Okay, and then we just cross this value out, and sorry, this should remain 4, and then we decrease c2 by 1, so it becomes 2. And then because now j, the current value of j is 1, which is already its limit. So we finish this iteration, and then finally we just finish all the part of the counting sort. So what we get is an array B. With all the values sorted, 0, 0, 2, 2, 3, 3, 5. So it's like
the same values as array A, but in their ascending order. So yes, that is how we get the value sorted, and this is how counting sort works. And before I so now okay, I still haven't finished counting sort because I want to let you know how to infer the complexity of a code. So when we want to infer complexity of a function, there are only two parts that we need to pay attention to. The first part is loops, and the second part is the function call. So whether if it calls another function, we need to take that into consideration, function call. So here, let's just look at the function this function counting sort, because it's relatively easy for us to start considering the complexity of a code. So here the first loop we have is the for loop right over here. So how many iterations are there in this for loop? So because we are going to increase I from 0 to k, so there should be k plus 1 iterations. And then the next for loop is right over here, okay? So how many iterations are there? The length of A. So because we are going to increase j from 1 to the length of A, so it's going to be n iterations if we use n as to denote the length of the array. And so after that, okay, we say this for loop, how many iterations are there in this for loop? Because we are going to increase I from 1 to k, so there are just k iterations. And in the last for loop, so because we're going to decrease j from the length of the array A until 1, so there are going to be n iterations. So because here, because all this, there is no two layers of, there is no loops of loops. So we just sum them up, and that is the total complexity. So if we sum them up, we can say that it is going to be 2n plus 2k plus 1. So by default, if we want to consider the complexity, when we infer the complexity, we want to get rid of the constant values. So if we remove all of them, and then what we end up with is just O n plus k. That is why we say the complexity of the code is of counting sort is n plus k. Okay, so this is how to infer the complexity of a function. And so far we have learned 5 sorting algorithms, but one of them is just optional. So we have insertion sort, O(n) square complexity, merge sort n log n, and quicksort. Which is n squared in theory, but best in practice. Then we have counting sort, O(n) plus k, but it has one limitation, which is that all the values in the array must be integers from 0 to k. So these are the 5 or 4 sorting algorithms that we have learned, and then we are ready to close the first section of the course, which is the sorting algorithms. So okay, and for after this week, you should read chapter 7.1 and 8.2, and also you will have homework 3, which asks you to implement quicksort and counting sort. Okay, have a fruitful